Yeah. So now we are going to go cell by cell and describe how to create a graph database, how do you get data into the graph database. So we are going to talk about that. We are going to take some sample small data like we did in the RAG case too, take that data and convert it into a graph, and then we will briefly talk about how the graph would look like. So here is how we start. So the important thing is we are setting up some environment variables, though they are not super important, but what is more important is we are using a Neo4j graph, and this is going to be the graph database we are going to use. So Neo4j graph is the graph database. The graph database has to be installed on the DGX. It is installed at this URL. So you can note it down if you want, or anyway you can see this video later too. It needs a username, it needs a password. So that is the username and that is the password for the Neo4j. This might change and we might give you a different username and password when you actually work with the DGX. And this second cell is instantiating the Neo4j object, that is, it is creating the graph database. We do not have anything in the graph database as yet, but we are just creating an empty graph database in which we can store the data which will be the graph which will be created, but we have not yet created the graph, so we have nothing to store. Now here, as you can see from this line, we are going to use the OpenAI, that is essentially ChatGPT LLM or the OpenAI LLM in order to convert from our textual version into its graph version. We are going to engage that LLM to make that happen. We are going to use the OpenAI LLM, the ChatGPT LLM to do that. That is why we have got the OpenAI key over here, and we will see how to use it. So I think now I will exit out of this mode, and we can now scroll down and let us see how we are creating this. These steps are super important, these 4 steps where a lot of stuff happens. I told you that in order to take a piece of data, piece of text, and convert it into a graph, I need a thing called object called a LLM transformer, and an LLM transformer needs an LLM, a large language model, for its creation. So let us see what we are going to do. So in this case we are getting an LLM graph transformer from one of the LangChain graph transformers. We are getting that, but that needs an LLM. So we are, the API that we are using is again a LangChain API for ChatGPT or Chat OpenAI. Okay. So now we are instantiating the LLM here. This is a very small version of a LLM. So this is Chat OpenAI. Temperature is equal to 0, because in this case we are not expecting the LLM to produce any textual output. We do not want to test its creative skill. As temperature rises, the LLM becomes more and more creative. In the present instance, we do not want the LLM to be very creative. In fact, we want it to be pretty conservative, stick to the facts. So we have set the temperature as 0, and obviously we need to give the model name, which is, this is the small model which we are using, not the full scale GPT-4, but GPT-4 0125 preview version, and then that is the LLM. But the LLM does not do the trick. We need a graph transformer which needs an LLM. So the LLM is used to analyze the text. The graph transformer takes the text which is analyzed by the LLM, and using the LangChain philosophy, takes the output from the LLM and prompts the LLM, takes the output from the LLM and asks it to build a graph which will later be stored by us in the Neo4j which is the graph database. Okay. So, now that we understand this cell, let us get a little more ambitious and work towards the next cell, but before that let me erase this part, and then let us scroll up for seeing what is happening there. I think I will have to exit. So, let us scroll. Now we are at the right point. So, now comes the important part, where we are going to take a piece of text and ask our transformer to convert that text into a graph data structure, which we are then going to store in our graph database. Okay. So, we are going to do it at a step by step. Again, I will try and elaborate as each line goes. It is pretty easy, and I am sure you will get it in no time. So, we are importing the document object from LangChain core documents. The text is some text which we have taken, sample text, which kind of describes Marie Curie and I think her husband Pierre Curie, who are both winners, who are the first couple to have won the both of them who have won independent Nobel Prizes, and she was also the first woman to become the professor in University of Paris. Obviously, everybody knows her, but the idea is not to teach about what Marie Curie was or was not, neither to say that her husband was a French citizen, or she was a Polish citizen, or whatever. We are just interested in the text. So, now let us see what we do. So, documents is equal to document, page context is equal to text. So, we are creating a list with a single document object whose page content comes from here. So, this is the page content. So, I have created a document object. That is very similar to what we do if you have been following our LangChain example also. We create initially a document object. Now, having created a document object, what do we do? Actually, we interpret it as a list of document, but we know that it is a single document object. Now, we have created an LLM transformer one step earlier in the previous cell. We have created an LLM transformer. So, we are going to call upon the LLM transformer and ask it, this is doing a very important step, convert to graph from document form. So, we are calling a method called convert to graph documents, which takes this document object and converts it into a graph. So, at this stage, this would represent the graphical representation. So, this would be the graphical representation. So, I would get a nice graph, in memory, and then if I want to see the graph, kind of, if there are visualization tools and all that, which will enable us to see the graph, but that is not the intention at this stage. I just want to see, because there is only one document, so document 0, graph document 0 dot nodes, what are the entities identified in the graph, and what are the relationships among those entities. I can have that printed, and as you can see here, it prints the entities here and the relationships here. So, these are the entities or nodes as we call it, and these are the relationships. So, we get both, we get the entities and we get the relationships. Now, if you were to look at this carefully, I think it is fairly easy to identify what are the entities or nodes. Each node has an ID and a type. So, the type has been defined as person, node is Polish, type is nationality, and it goes on. Okay. So, I am not going to go through all the nodes because that will change depending on the data. Only thing I would like to point out is that every node has an ID and a type. What is the class of the node or type of the node? So, these are the nodes. Then what is the relationships which has been identified? Let us talk about one or two relationships. So, we have a relationship here. Every relationship has a source and a target. That means the relationship goes from here to here, and the relationship of course has a name. So there are three parts to a relationship. What is the source of the relationship? What is the target node of the relationship? And what is the name of that relationship or type of that relationship? So let us start. So this relationship, source is equal to Marie Curie. The relationship starts at Marie Curie, type is person, target node is Polish, and type is nationality. Now let me rub this so that we can scroll to the right. Let us scroll to the right. No, I don't think we need. Yeah, so let's follow this relationship. So let's go through this relationship. Source is Marie Curie, type is person, target is Polish, type is nationality, and the type of the relationship is nationality. Now this is to be distinguished. This is a type of a relationship, and this nationality over here is a type of a node. So they are two different things. Like that, there are many relationships which are identified. So here is another relationship. So source node is Marie Curie, type person, target node is Nobel Prize, type award, and the type of the relationship is award winner. This is the type of the relationship. So very nicely it has captured the nodes in our data, the relationships in our data, and for every node it has captured both the ID and the type of the node. I think that is really very wonderful that in just one call I have been able to translate a document into its graphical representation, and this graphical representation can then be used very well, as we will see in a later session, in conjunction to answer questions about the document from the graph representation. So using of course an LLM. Okay. So now let us rub this off and exit this, so that we can see what do we do after this. Okay. So there is not much which happens after this. We can also, this is just to show that we can only retain part of the graph, and we do not need to look at the whole graph as such. Or we can limit the understanding of the graph to only certain type of entities. If we choose to do that, we can do that. Now in the earlier case we did not do any limitation. We got whatever the entities, whatever the nodes which were created, we took, whatever the kind of relationships were created, we took. But there is a mechanism to do a filtering during the graph creation process, where we could say that the only type of entities I am interested in are these, rest of it is the same. There is a graph transformer. That time we gave only the LLM as a parameter, because we are not interested in filtering out certain type of graphs, certain type of nodes or certain type of relationships. But if we are interested, we could say that allowed nodes, allowed relationships, we could filter out some of it. Normally what people do is, people would do the earlier thing first, examine the nodes and examine the relationships, then perhaps decide based on the kind of questions they are going to get, that what is the kind of nodes I need, what is the kind of relationships I need, look at all of that, and then set up this filter that allowed nodes are so and so, allowed relationships are so and so. And once you do that, you can do this again. This is an LLM transformer filtered, which is an LLM graph transformer with these conditions. Convert to graph documents, again the same documents which we had earlier. So this time we will have limited number of nodes and limited number of relationships, limited type of nodes and limited type of relationships. So we can print them across. So now you can see the only type of nodes and relationships which we got are nationality, located in place of that nationality, and then we got worked at, and then we got spouse. So those are the kind of relationships we had. So if you want, we can restrict it to that also. Well, this is when I have two documents and I want to do comparison between the two documents. So I want to control the kind of entities which are created, kind of relationships which are created from one document, what kind of entities and relationships are created out of the second document, so that I can compare apples to apples, mangoes to mangoes. For those kind of projects we would probably need this, but otherwise it is okay. Now, having done this, having got the graph, what do you have? We have only one step left, which is graph, that is store the graph. Graph is our Neo4j graph object, to which we add these filtered documents or the filtered graphs. Add graph documents filtered, and there you are. So in place of the vector database that you created, in case of RAG, we created a graph database and added these graph to the graph database. So that is all, and these documents, these graphs get added to the graph database, and tomorrow or in a later session we will explore how to go and use this graph database to answer queries. So this is what we are going to do.